Okay, Happy New Year. It's January 4th, and I just want to go over one more problem like what we did in class today, just to give you a better idea of how to do these. This position function is t to the fourth minus 4t cubed plus 8t, and we're only interested in the domain from 0 to 4. So we know that s of 0 is equal to 0, and s of 4 is equal to 32. So the displacement's easy. The difference between where it stops and where it starts. And so the displacement's equal to 32. That's pretty simple. Okay. The distance traveled, the total distance traveled, is a little tougher because we've got to figure out if this particle backs up and changes directions or anything like that. The way to do that is to find out if the slope or the velocity is equal to 0. So let's take the derivative and let's set it equal to 0. And you can verify all the algebra here. I'm going to show it to you. First of all, I know that there's a 0 when t is equal to 1. You can tell that just by looking at it, which I did up here. If t is equal to 1, it's 1 minus 3 plus 2, which is equal to 0. So I know one of the zeros of the derivative happens at t equals 1. And then I do some long division to figure out what the rest of it is and factor out that t minus 1 factor. Okay, and it turns out what happens is you end up with the t squared minus 2t minus 2 after you do the division, and you've got to do the quadratic equation to figure out what the other two roots are. Okay, here are the other two roots, 2 plus or minus 2 square root of 3 over 2, which simplifies at 1 plus or minus square root of 3. Let's make that look like a square root of 3. I did it the first time and I made a mistake on that, so that's why it doesn't look very nice. Let's put a square root of 3 there. There we go. Okay, so here are the three roots then. T minus 1, and then 1 plus square root of 3, 1 minus square root of 3. Okay, I need to figure out and verify first that these are minimums and maximums of the particle. So I can make a sign chart to do that. And I'm going to go ahead and just rewrite that up there. The function and its derivative, and this is the factored derivative, and so from here I can figure out the sign chart. Okay, my domain is I'm only interested in from 0 to 4, so this 1 minus square root of 3 is negative, so I don't really care about that root. I want to divide the rest of the domain, the 0 to 4 domain, up by the other zeros that I found as critical values, so at 1 and 1 plus square root of 3. If I do that and I figure out what the signs of each of these factors are, I can come up with the derivative is increasing between 0 to 1, it's decreasing between 1 and 1 plus square root of 3, and it's increasing again between 1 plus square root of 3 and 4. So the function's going forward, or the particle's going forward, then backwards, then forwards. And I've got a max and a min at the zeros of the derivative. So now it's just a matter of plugging in the values. Since I know the particle starts at 0, goes forward, changes directions at t equals 1, changes directions again at t equals 1 plus square root of 3, and then stops at t equals 4, all I have to do is figure out what the positions are at each of these endpoints. S of 0 is 0, S of 1 is 5, S of 1 plus square root of 3 is, according to my calculator, let me look real quick, is equal to negative 4. So this is equal to negative 4. So the particle goes from 0 to 5, 5 to negative 4, and then S of 4, I already found out from the last screen, was 32. So it's going to back up, and then it's going to go forward to 32. So here it starts at 0, goes to 5, then goes to negative 4, goes out to 32. Total distance traveled is 5 and 9, this distance here, and 36 more. And so that's going to be, it looks like 50 units. That's the total distance traveled.